What I found was that a lot of companies, every company needs something and every something. They like their companies that exactly. So they definitely have this kind of I just don't know kind of notes. Yeah. Don't do that. Actually, there is
All right, so I guess we'll get started. Hey, everybody. Thank you for coming to the Data Hub, and thank you for coming to the Lunch and Learn series with ODX and Communitech. I believe this is our 5th event here at the Data Hub for the Lunch and Learn series. And today we are featuring David Shack from Caspy. My name is Tyler. I'm from ODX. ODX is an organization that was built to help companies commercialize using open data. So we offer a lot of services for companies that are looking to integrate open data into their businesses or are already using open data. And a lot of our services are free. So we help companies find and use data. We help companies link up with different levels of government to use data. So if you have any needs like that, reach out to me after the event, and we'd love to help. After the event, I'll tell you a bit more about events that are coming up. But for now, I'll pass it back to David. And just one note to the people online: if you have any issues with audio or video, just type in the channel, and I'll try to address those issues for you. Anyway, enjoy. Thank you.
Hey guys, I'm Dave. So this is the first time I'm giving the talk. I want you guys to give me a little bit of feedback on what level you'd like to talk at some point. Maybe you can throw some questions out, that kind of thing. And here are my coordinates. You can catch me later and tell me what you thought. Ask me questions, that kind of thing. I might be a little slow getting back to you because I run a startup and I've got lots of stuff going on, but that's how that goes. So I've been doing products and companies for a long time. I've always been sort of the tech part of companies. And I've always had a huge product focus, and I've always had a huge data focus. And that's kind of what got me into machine learning and big data. So around about like 5 years ago, I got into big data, and also machine learning was part of that. So one thing that I wanted to tell you a little bit about in this talk, and we'll do a little bit of high level, and then we'll talk some low level, is machine learning is a pretty daunting thing. Like, it sounds complicated, it sounds like there's a lot of science involved, and there is. But the awesome thing is you can get into it pretty easily, and you can get some results pretty easily. So don't get too intimidated. And if you're reasonably competent at programming and sort of tech stuff, you could probably spin something up in a weekend that would give you something, and you can go, well, I accomplished something. Right? If you have a data set already that has the right bits and pieces, and we'll talk a little bit about that, then you can spin something up fairly quickly, and that's pretty neat. We'll talk more that going from that to something that's productizable and usable, that's a whole other story. But it doesn't need to be that complicated. One thing that we did a lot at Caspy is we talked a lot. We did a lot of unstructured. We deal with email, and I'll talk a tiny bit about Caspy on the next slide. But we deal with email. Email is unstructured, and you guys all know what unstructured means. Unstructured is sort of I don't know, maybe it's the worst kind of data. It's like it's not categorized. You can't slot it into anything. You can't sort of compare bits and pieces to each other. It's hard to use. Turns out humans are really good at it. Computers are not so good at it. And email is sort of the classic unstructured bit of data. It's got some metadata, which is awesome, but it's also got a huge amount of unstructured data. I'll talk a little bit about an approach, like how to go about getting into machine learning and getting something usable. Like I said, the first bits don't need to be that hard, and I encourage everyone to do it. I think the awesome thing about machine learning as it is right now is, if you guys have just started, if we had started 5 years ago, we'd be all doing PhDs. Now things are sort of mature. Things are, you can go to Amazon or Azure or Microsoft, and they've all got platforms that are out there that you can just feed your data in, and things can sort of start to work. So don't be intimidated. Okay, Caspy plug for 2 seconds. So I work at Caspy, I'm the CEO. Go there, sign up, have a look. We like I said, we do email. We look at email, and we're focused on relationships. So we do sort of what we call a headless CRM. Watch your business communication, understand your business communication, and advise you on what to do next with clients, that kind of thing. So you can imagine that's pretty complicated stuff. There's a lot of natural language processing, lots and lots of human communication in there. So what I'm talking about today is one element of that, something we sort of started with, that started it all, and now we've got a huge amount more, and things are moving. And I can talk about Caspy all day, and that's fine. So can an AI really predict, should I reply to this email? Yeah, this is hard. So imagine looking at an email, everyone's got their email. Imagine looking at it and saying, what are the elements, what are the bits and pieces that tell me whether I should reply to this email or not? It's pretty complicated stuff. This is kind of the approach that we take. And one of the things about machine learning is you start off with the premise, right? You start off with like, hey, I'd like to be able to solve something, and the solution is solvable, and it's solvable by a human. So that's a pretty good start, right? So there's there's enough data so that a human could do it. There are some problems, some people have approached me and asked me, could AI solve this problem? And I was like humans can't even solve that problem with that kind of data. So clearly a computer couldn't either. And a good way to sort of structure the thought process around machine learning is like break the problem down into its elemental bits and how a human would do it, or maybe even more basic. What are the sort of what are the things that would make a human say this is important, this is significant, or this is not significant? So that's kind of where we're going to talk about now. So yeah, so could a human do it, and how would they go about it? So let's look at some bits of an email. So you get an email, and just to back up for 2 seconds, this is kind of how we sort of began the project. Before we even wrote code, we said like, okay, we want to solve a problem, we want to figure out who can reply to an email. How do I do it? And it's sort of a introspective kind of thing. Like you've got to sit down and you say like, okay, I'm now pretending I'm a computer and pretending I'm thinking about the things I'm thinking about what am I seeing? What am I doing? And that's kind of where we hit this. And it's not the same for all problems. Some problems are, I did a lot of stuff with financial data. It's not quite the same thing with financial data. This is a much more unstructured problem. So things that I care about, things that might influence my replying to an email. The sender is the first one. So sender is complicated, but it's things like, if it's your wife, you might reply right away because it's super important. If it's a spam email, it's a newsletter, you probably won't reply. So sender is hugely significant, and clearly, like there are some senders that are like, I've been waiting on this VC to get back to me for 2 weeks, and I don't even need to look at the content of the email. Like I'm opening that thing, knowing that I'm going to reply right away. I got some of those emails this morning. That I was like, I don't even need to read it. I'm going right to the reply because I know I need to. Subject is, well, anyone who's ever written any marketing emails knows subject is a gigantically important thing, and there's all kinds of things written about it. Compelling stuff, not compelling stuff, but certainly subject is the other part of it. Subject, well, it's supposed to be exactly what it is. Like there's a body of email somewhere else. Here's the title of this email. Is it compelling? Is it asking a question? Does it sound angry, happy, sad, all this kind of thing? So that's another part. So do I care is complicated, and this is sort of something that we did later on in Caspy. Do I care is once I look at the email, like, is it for me? Is it about me? Is it something I care about? So I'm a plumber. I'm getting an email about plumbing. Well, I probably care about that. That's important. If I'm getting an email about, I don't know, dance, I'm not sure I'm getting that, but I probably don't care as much about it. So it's like related to what I am, who I am. So that's another thing that sort of helps me judge whether it needs a reply. And you can tell I'm sort of alluding to, well, these are the things I'm going to get a computer to do soon. So sentiment is stuff like, well, you guys probably know what sentiment is. Sentiment is angry, happy, emotional stuff, sad, urgent, those kind of things that are sort of like, I'm taking a sentence and I want to extract the emotion out of it, extract some human out of it. And that's what sentiment is. And there's good and simple and bad stuff online. And you'll see later on, I talk a lot about iterating. So go with simple always at the beginning. And you can just somewhat judge sentiment just by picking up words. Tone is super complicated. Tone is stuff like, well, I just know what the words say, but what do they mean? Which is really, even humans have a hard time with this sometimes, and written is hard. And computers are just starting to sort of do this stuff. And the interesting thing about machine learning is you don't always know why it's responding, why it's thinking the way it is, or why it's responding the way it is. We've seen some things that look like it's understanding some tone, which is kind of neat in our system. And then I have like this most basic of things, and we have lots of these kind of basic things. Like how many question marks are in this email? So you can count those up, and we have proof that more question marks in an email is more likely to mean it needs a reply. It doesn't necessarily mean that, but it is more likely to mean that. And there's a whole bunch of these kind of little simple things even like size of the email or how fast the person responded to you. Like there's a lot of these sort of like extractable meta bits of data that if you can find them, they can allude to, and they can help you predict that. So when I'm talking a little bit about the human elements of breaking down a problem, a lot of what we did was instead of just feeding a bunch of text into machine learning and hoping that it comes up with answers, like using what everyone calls domain experience. And it turns out like with domain experience, with email, domain experience is like, well, everyone's got domain experience in this room, I think, with email. If you ever reply, if you replied to more than 1,000 emails, you have domain experience, and everyone has. So why? So imagine. So all those things are doable. It gets complicated when you have 150 emails a day that are not spam. You have thousands of contacts. These are all these emails that are coming in are you can solve the problem of whether I should reply or not, but it's a task, it's work. When we started off with Caspy, Caspy was supposed to, we meant Caspy to be for service-based businesses like plumbers. Get a lot of email every day, but it's not their main goal. So you can imagine going through all those steps that I described earlier for this many people and doing my day job. That's tough. So another way that we sort of worked on this problem before we worked on the real problem was, okay, now I'm trying to think about how I would instruct a person to solve this problem for me. So this is a great way of figuring out how I'm going to teach the system something. And maybe there's a way to instruct, maybe there's a way to kick it when it's not doing the right thing, and maybe there's a way to praise it when it's doing the right thing. Again, you can tell I'm alluding to machine learning stuff here. But if I was to train an assistant to do this, how would I do it? So, so one thing that the assistant would do would be get to know me and get to know who I care about. It's so getting to know me well. That's an interesting thing. Getting to know who I care about is also part of it. But the way that my assistant would do this, if I had an assistant, they could either learn it from me and I would just give them a speech, or they could read a ton of email from the past and see what I have replied to, what I cared about, what kind of things I said in those emails. So you can look. Yeah, I mean, certainly, like I am in my email, and you guys are in your email. Like it's you. Like you're. If I wanted to learn about you, I could just look at your email. So getting to know what I care about is important. Getting to know who I care about is important. All that stuff is in your inbox too. So how fast did I reply to people in the past? What did they say to me? Like, what did I say back? A lot of information about my contacts is in my email. And it's not just like their coordinates and their email address. It's like how much I care about them. And I always make this joke that Caspy's got really complicated stuff to figure out who's important to me. And under the covers, you can tell who's important and who's not important. I always joke that it says that my wife is number 3 on my list, which is, maybe according to my email, that's what it looks like, but that's not. So the great thing about humans and the not so great thing about computers is supervised learning is easier done with humans. So if my assistant comes to me and says, look, I think this email is really, really important, and I say, no, it's not that important, and I can say because. I can say because I don't think that person is very important, or because this doesn't look urgent enough, things like that. So I can give them back a because. So one of the challenges with machine learning is you can't do a because. You can often just say, no, that's not important, and you have to ask you have to hope that the AI learns and infers over time what I meant, or why I didn't do that, or why I didn't like that thing, or why I did like it. So, so that's what's one thing there are some ways to do this, but we haven't found a good user interface to do these kind of things. And this comes down to how do you praise the AI for doing the right thing, and how do you tell it didn't do the right thing and why? So, we built it. Hint is iterate. I'm sure that all of you know that iterating is an important part. So, simple features first. So, I was going to cover what a feature is. So, in machine learning, the term feature is an atomic bit of data. It's an element of data. So, number of question marks in email is a feature. Forget about why it's called that, but it's not the greatest word. And machine learning has a few words that I would have chosen differently, but they're called features. And one of that thing you feed into an ML model is a vector of features. So like just a set of features. So steps to get things moving. Simple features first. So when we started off, we weren't trying to do natural language understanding. We weren't trying to do complicated, why is this person important to me, and all that kind of stuff. We were just trying to find some metadata that we could plug in. So number of question marks was in there. Time to respond was in there. How big the emails were, like all these kind of things that were sort of envelope things, metadata stuff were in there. And that's, we probably found 50 of these things, which was interesting. And we built them over time. And we were playing over time. So when I'm talking about playing with these features, I go back to something that I heard probably when I first started machine learning, which is 90% of machine learning is feature engineering. I don't know if you guys have heard this term, feature engineering. It's sort of a tenet of machine learning. So feature engineering is engineering the inputs to your model so that it is most likely to make an accurate prediction. So what this boils down to is process of using domain knowledge. What this boils down to is sending confusing data to the ML models will give you bad results, or sending ambiguous data, or sending data that contradicts itself is all bad. And of course, these are again similar things to if you're trying to train a person or train your dog or something. Giving them mixed messages is not a good thing. So we extracted a lot of features. We extracted lots of stuff, and we got things going. So during the extracting of features and removing of question marks and that kind of thing, we had a few people on the team that were saying, like, can't the AI just do all of this? Like, couldn't you just feed it? Well, couldn't you just feed it all the information, all the text, and then give it an outcome, and then say, like, black box, please just do it. And frankly, without extracting any features, without taking question marks out and all this kind of stuff, couldn't you just feed the whole lot in there and have it do a predictable, or make accurate predictions, or make some predictions? And the answer is yes. Like, sure you could. It wouldn't work as well, or you'd need a ton of data. So if you imagine, like, you feed paragraphs of data in, and there are a bunch of question marks in there. At some point, if you've got the right AI models, it would figure out that question marks mean something. But my sort of dissertation on letting the AI figure things out is, like, if you have domain knowledge in something, if you know something is going to be significant in a prediction, just take it out and relieve the AI from figuring that out. Like, if you can figure something out, if you know, like, question marks are significant or time to reply is significant, like, extract it. Like, that was part of our. There was a debate on our team about this, and we ended up doing some tests that, proved without a doubt that we could get much better results if we extracted a ton of stuff out. So feature engineering that we did, ambiguous stuff, like I said. So if you imagine, so I'm trying to think of ambiguous stuff. So we talked about sentiment for a second. So imagine we have a feature for sentiment, and we have a feature for number of swear words. These things mean similar things. So let's say eventually you evaluate that the feature that is number of swear words is weighing 8% of the prediction, and the feature for sentiment is weighing 7% of the prediction. If you took one of those away, actually, if you took the number of swear words away, you could eventually the models would line up more on one, and it would have a higher predictability. And this is what I mean by ambiguous stuff. So over time, we figured out how to understand which features are causing problems for us, or we're correlated, is what it's called. Refined data. So we also threw a lot of features in that eventually proved to not be significant, in the hopes that they were going to be significant. Like, sometimes you throw data in, you're like, hey, I think, I don't know, number of commas might be significant, because that, I'm not sure, maybe it is. Well, it isn't. So we took those things out. We found, comes back to, like, count the question marks. So we found a lot of little tidbits in the metadata and in the text to just extract and feed to the models. And again, remember, like, we're not even doing natural language processing, natural language understanding yet. We're just doing simple stuff. And I'm a huge advocate for, like, don't crack gigantic nuts until you need to. So we, without doing any natural language processing, all that kind of stuff, we got to 64%, or we were able to predict 64% of the time whether an email needed a reply or not. So in the past, we'd pick an email and we'd say, let's predict whether this one needs would have gotten an email or should have gotten an email, and then we also have the whether it did or not. So 64% of the time we were right. So and we did this in a very short amount of time. I won't tell you how much time, but it didn't take that long to get to this point. 64%, pretty good. So like I said, better than a coin flip. So like, and to some extent, that's black and that's like magic. If you could say like better than a coin flip, that's like if you could go to a casino and do anything that was better than a coin flip, you'd be a billionaire. Like you would be, like it's that's all you need to go the whole distance. You know, it's somewhat predictable. You've proven that it's somewhat predictable. So this next slide took months and months and months and took forever. So going from 64% again to 90% is, well, staggeringly difficult. And sometimes 64%, like I said, if you're trying to predict, I don't know, casinos, like you stop at 64% and you're good. If you're trying to predict, you know, whether if you should give advice or not, 64% probably isn't good enough. So depending on the need, will help you judge how much better you need to be. We decided that 64% wasn't good enough to advise people on things. So then we tackled the hard stuff, and we tackled natural language processing and natural language understanding. So parts of speech is another comedy bit that I like to talk about. So it uses machine learning too, and we can talk about how machine learning is using parts of speech or parts of speech is using machine learning. But it's able to do stuff. So the parts of speech processors, we used 2 of them. We combined a bunch of stuff. We got some stuff working, and they were able to do things like tell the difference between what's the example? I'm eating pizza with anchovies. So that sentence, they were able to do stuff like to know that because they've learned that they know human language and that kind of thing. They know pizza has anchovies on it, as opposed to I'm eating pizza with like anchovies, like fish, or I'm eating pizza with like utensils that are anchovies. So they were able to sort of understand the nouns and the verbs and the relationships. So that's through natural language understanding versus just sort of parts of speech processor stuff. So classifiers are another type of, a whole other branch of machine learning. Classifiers are given a bunch of data, what is it closer to? So, or what topics is it closer to? So in the case of an email, you could feed it a bunch of sentences or paragraphs or break it down however you like, and it could say, this text is more like plumbing than it is like dancing. And you could also say, this thing is also able to do things like, this person is more likely to respond to plumbing than it is to dancing. So classifiers are, you can find some canned ones online and they work okay, and we modified a bunch of stuff. And so that's, so we cracked open this nut that was the text, and that's complicated, and parts of speech processors create trees, and how do you get that into vectors, and that's complicated, and all that kind of stuff. So we trained and we got better with all that kind of with those kind of new features, and then it becomes a tuning exercise. So we play with the models, and we started off with some pretty simple models, and then we started to even do things like tune the neurons. So the neural nets have different layers and different hidden layers and stuff, and some neurons have higher affinities for different inputs, so we change some things on those neurons. We can talk some more detail later. Come talk to me. So the other cool thing that I was alluding to is understanding relationships. Who's ignoring it? So that first thing I said at the beginning of the talk, like sender is gigantically important. We got some pretty good results on who's important to you, why are they important to you, and like even things like historical stuff, like what's the path of your relationship with them, which is interesting, and people like that stuff, and we're presenting it to people. So we were able to do things like, this person looks like they haven't had love in a while, so your relationship is getting lower with them. So you should investigate increasing that relationship. So it's complicated stuff again. But it was again, iterative, and it was fun, and it was we didn't really put a marker in the sand as far as how good we wanted to get, but we got to like 90%. So I'll say sometimes it was like 93, and some, depending on the training data. So we were with 90% confidence, if we get an email, we can predict whether a response would have been required, or whether you would have replied to an email, which is interesting and awesome. And maybe 10% of the time we're failing. It's okay. We're still doing okay. So that's all that how we built this stuff included training. But I thought I'd talk a little bit about training because it's fun, and it's sort of elemental to machine learning, and we're in the data hub, and data is sort of elemental to training. So yeah, we're in data hub. So email is private, right? Email is like I said, everyone, you're in your email. Your life is in your email, and my life is in my email. I don't think I have anything too scary in my email, but I'm in there. So it's hard to ask for open sources of data that are email. So we had to figure out how to find open sources of data. And of course, the third point here, like, our own data is great, and we had a few people that were willing to open their inboxes up for us, and that's awesome. And we can talk about privacy also. But we still wanted more and more, like as much data as we could get. So we looked for databases of emails online, and there aren't many. But it turns out that the way a lot of emails get online is they get hacked, and people get sued, and those emails get online. And so we found a bunch. The two ones that you probably know of are, like, Hillary Clinton's emails are online, or at least a lot of them are. And of course, like, most of them are pretty mundane stuff. Enron has 1.5 million or so emails online, databases all over the place it's just like, if you want it, it's there. And again, most of it is mundane stuff. Most of it is like, what are you doing for lunch today, kind of stuff. Some of it is like, burn those files, I'm sure, but whatever. It spans the range. So a note on finding data, right? So one of the, and I've given other talks on, like, finding data where you don't have it, and it's tough, right? Like, there's this whole internet out there. There's so many people on the internet. How do you extract data from those people? And we've got, in other projects, we figured out creative sort of ways to do it. And I guess my only point here was, like, if you're lacking in data, you've got to figure out a way to go get it. And sometimes that means enticing people to go click on stuff. Surveys kind of work sometimes, but they don't work that well. Like, you've got to make stuff to go find data. We used some Twitter data too. And I can talk about that. We can talk about that offline, but we created a little app that a bunch of people came to our site, and they gave us their Twitter handles, and we'd look at their tweets, and we'd learn stuff. It was called the Donald test. So we could tell whether people sounded more like Hillary Clinton or Donald Trump. Anyway, that's another comedy story, but that got huge amounts of press and huge amounts of interest. And we got tons of data from it, which was neat. So yeah, sometimes along the way, you need to create a little sub-project to help your main project. And that was what we did here. We've got others. So, what's the perfect ML loop? We got some fun. So this relates to this data problem that I'm talking about. So data is great, and having masses of data is great, but to do machine learning, you need to have the outcomes. So if you're trying to predict on a reply, for example, you need to have like the data, and you need the outcome. So you have an email and the outcome was you didn't reply, or you have an email and the outcome was you did reply. So with that, now you can move ahead. If you just have a bunch of, I don't know, like web server data of people visiting your site, and you want to be able to predict whether they would buy your stuff or not, like there's nothing there. You can't do that. Like if you had things like if people visited your site, you understood the path, and then you understood that they went and bought, then now you have path and outcome, and now you can do predictions on that. So it turns out that email is a perfect sort of ML loop that we have there. The raw data and a lot of historical data, like of the data that led up to that data, and we have the outcome, which is magic. And you don't have this often. And a lot of times people come to me and will ask me like, hey, like how do we get machine learning on this thing, or how do we predict on this thing? And I'm like having data isn't enough. You need to have the outcomes too, or you need to have the thing you're trying to predict as well. And that's not always there. And we're working on a project, helping out on a project that is doing has a recommendation engine, and the recommendation engine requires outcomes. Like here's a bunch of data, here's a bunch of interesting stuff, but did they like those recommendations or not? We don't know those things until we present them. So again, just a bunch of data is awesome, but you need the outcomes. And so actually sometimes what you do also is like grunt work and hire someone or do it yourself and fill in the outcomes. And that works too. We can also talk about how much data is enough for machine learning some other time. So we're getting near the end. So one thing that I can also say is email is a great source for stuff about you in there. So we built a product that understands relationships and understands and is able to advise on things, but wow, there's so much more stuff to be gotten in there. And I don't know, things like purchasing stuff. And I mean, and Google does some of this stuff for you already, but like this, this is one of my encouragements is we're going to be mining all this stuff for more product stuff. And there's no end of information in email, inferences and stuff like that. So I'm super keen on, and I've kind of always been an email guy, but I'm super keen on how much information is really in there. And one might ask, like, is email ever going to die? And my answer would be, like, no, probably not. Like, it's got a niche. It might change over time, but we can talk about that futurist stuff too. But my gut is there's tons of stuff in here. There's going to be more stuff in here, and it's not going to die for a long time. Yeah, that's it. So I have some other bonus stuff at the end if we want to talk, but that's me. You can email me for sure. Tell me what you thought about this, and if you have some questions about anything I've said in here, then please email me. The bonus material is Donald Test and Tweet of the Hour. We can talk about those things another time, but we can put it to a stop right now, and then thanks very much. Oh, yeah, questions?
Yeah. So you talked about the theoretical kind of things that you should do to approach a machine learning problem. What is the recommended technology path? Because you said you could do it on a weekend. Right?
Yeah.
Do you have some recommendations on
So
where to do this course?
So Microsoft has Microsoft has a prediction API or in a prediction site, I suppose, that lets you upload columnar data, so like spreadsheet kind of data, and with outcomes. And it has a nice little interface that lets you say, here's the predicted stuff and here's the not predicted stuff, and like that's what I mean by like if you get into it. So Microsoft's got some, Google's got some, Amazon, AWS has them too. So they all sort of start off with give us tabular data and identify some rows and columns that mean something, and we'll play with some data. And so, and a lot of it is like pretty black box stuff. Like you don't even know what's happening, which is why we eventually transitioned to our own, much of our own code and huge amount of work on our own side. But just to get you, like, is there some predictable data in here? You can do that again in a weekend, almost without much coding. So, you know, I don't know, you have 1,000 rows of some data with some outcomes, like you could feed it to AWS, and AWS's interface, which column is the one that has the outcomes? You know, that kind of like data import stuff. Like it works. So and that's the kind of stuff I'm talking about. Like iterating is awesome. And it's like at some point, like early on, we decided, okay, this wasn't enough, but that at least gave us some hope.
You mentioned that one of the pieces that was very important to look at was email subject. You ever look beyond the email subject line to find something in the body attachments?
Yeah, body. Yeah.
Do you know to repeat the questions?
Oh yeah, sorry. So the question was, did we ever crack open up the bodies? We talked about subject, and did we ever crack open the subjects or the bodies? And yes, we did. That was like the second part of what I was talking about. That we did all the natural language processing and the categorizational stuff. So that was all on the bodies. I should have been more clear on that. But yeah, we cracked open the bodies and we read it. We never looked at attachments though. We've never looked at attachments. So we may do that at some point soon. We probably should.
So how much of this would be influenced by the consistency of the user themselves, in the sense that, you know, I might not be consistent in the way I respond to some emails. So this is a your mileage may vary.
Yeah. So the question is how is this dependent on the user being consistent? And the answer really is, so we evolved sort of two ways of doing this. So we have like the collective idea of that how would the masses respond to this email or given these parameters, and then we have your sort of a ML brain for each individual. So we have yours. So definitely inconsistencies in machine learning data make things harder to predict for sure. But since we have this basis of the rest of the world says, given these parameters, it looks like a replyable email. We might tell you, hey, this looks like a replyable email given you and the rest of the world. And eventually, over time, we have these two brains. We have the sort of collective brain, and we have the brain that's responsible for your stuff. Eventually, they start to diverge, but not by a ton. So, yes.
How do you deal with slang? So you're dealing with one language or something?
Yes, only English right now.
But we all have different terminology and slang. And then the second part is, how do you deal with industry-specific domain words or even corporate words, right?
Right.
So you used examples like features and vectors.
Yeah.
They also have all these other meanings. I mean, that's why dictionaries exist.
Yeah.
All these different meanings for these words. So I was curious about that.
Yeah, so slang is not that bad because, well, I guess it's fairly definitive, right? Like the same slang means about the same thing. So it's you know, it has synonyms to some extent, I suppose, to real words. But so you know, like the categorizational engine stuff figures that out eventually, and we've even got some canned stuff that says these things are related, these words are related, and those are available online and like thesaurus type things, but not quite thesaurus. But the industry specific words, we haven't. It goes along the lines of this individual brain for individual people, and like we haven't cracked that nut fully yet, but we've got some ideas on. And we've got a Caspy for teams that's sort of building now, and somewhat being used. And the idea will be at some point that we build a brain for each company as opposed to each individual. So it would pick up on those things over time. And of course, part of the deal is we need to train on those data sets too. But language is super hard. Language is complicated as hell. But again, it's not too hard to get into it, and there's stuff online to help you with it. So.
Yes, application of this is to sort of flag emails that need a reply or put them into a separate folder. Like, I get all emails that don't necessarily need a reply, but sending a email.
Yeah. So the actual how it works is it right now it's an advisor Chrome extension. So it just drops down and says, hey, please do this right now. So essentially it's a tap on the shoulder. It says, hey, it creates to-dos for you. And it says, yeah, I think you need to do this right now, or you need to do this week, or you need to do this today. So it's less about priority filtering, and it's more about, it creates a to-do list. They're similar things, but they're not exactly the same thing. So it also does things like, hey, you sent an email a while ago, you should reply to it, or you should follow up on it. So we deal in to-dos as opposed to emails, which are kind of one-to-one sometimes, but not always. Wait, somebody there.
How did you go about choosing your model? Like, did you start with something simple, random forest?
Yeah.
Neural networks? How did you choose your thing?
Yeah, we started with linear regression stuff, and I mean, it probably even like when we were still in when we were playing with AWS for a while, and even while we were still in there, we started to play with different models and play with different ideas on how to move things ahead. So you can if you ever looked at the AWS like training stuff or the toy stuff that they have, you can change models and you can add layers to your nets, and you can change the propensity stuff like online. It's like some pretty graphs, and go there and have a look at it. So you can play with models online. So yes, we went from simple to more complicated to like really proprietary changing neuron stuff, which is, that's not that worked for us.
How you're storing the data, is that important? Because I mean, what kind of database you go with?
I mean, it's actually not that. So one thing, we don't store emails, which is key, because I was like, the idea of building software is sort of like, assume you're going to get hacked, assume all your data is going to get leaked at some point. So like, what would happen if we were storing a bunch of people's emails and we got hacked? That would be horrible. So we're not storing them. I never wanted to, I never want to see them, and I never, like that kind of thing. So it turns out that databases are not as important as you might think in machine learning. Of course we have a ton of stuff, and we're storing the models, we're storing them in databases, but it's less important than the model, like how you build the models. We use Mongo, but it's a big database. It works.
Are you finding now that the underlying services for ML and AI are becoming more commodities, such as natural language understanding, like training data sets and tools? Like, is it at the point now where we can use those as services to build on top of, or is it still wireless?
Right. Sorry. So the question was, other services that are how are the services online? And the answer is they're awesome, and they're getting better every day. So yes, you can. There's natural language understanding stuff. There's even things like there are processes out there that will give you like what the sentiment was and what this, like they'll boil text down to more elemental, like what did this mean, sort of things. The reason we couldn't do that with Caspy was because I didn't want to ship people's emails to online services. That would have been bad. So we had to do it all like online or by ourselves. In fact, we don't use any sort of third-party stuff. We started off that way, but we ended up not doing it. So start off with that. And frankly, like if you're using Twitter data or open data, like data that's already available, don't build your own stuff. Use things online until you're completely exhausted on those things. Yeah, because the stuff online is awesome.
When it comes to accessing some data, such as the economics of that's collaborating with companies who are open to using their in-house or from the which would you say you would like to have more of, and why do you think the economics is better for you to the other rather than this?
So which data did we rely heavily on compared to? Well, I guess none of it was weighted, I suppose. Like it was all just humans talking, and it was all humans sort of conversing with other humans, and to some extent that was all we looked for. That's all we needed. So like we couldn't really weight some emails as being more significant or more important than others. So the answer is we didn't. We just took all of them as the same thing. Enrons and personal and the companies that we had, we weighted them all the same.
So you talked about how kind of early on in your project you kind of started with a whole bunch of simple features and you kind of built a model and iterated it and kind of chose kind of which features you thought were important and which ones less important. I'm interested, like from a technical standpoint, like, how do you decide what's a good feature and what's a bad feature? Do you just like take a whole bunch of different models and then look at which ones perform better? Are there like actual metrics for saying, this is a good feature that is like a valid predictor, or this is a good feature that is not redundant with the other features?
So it's
or is it kind of like more like a fuzzy experience based?
So at first we were doing trial and error, which turns out, it took a couple hours to train and a couple of minutes to predict. So you could do a few of these a day. So we played trial and error. Over time we got better, so we added some stuff. We're using TensorFlow, using Google's TensorFlow stuff. So we added some stuff so we could figure out what features were important and which weren't, with some confidence. Some of the stuff online can start to do this now. Like just say, hey, I weighted my decision heavily on this feature and not so much on these ones. But that's trial and error. I can say a lot for trial and error. So that's where we started, and it works okay. But definitely as we progressed, we were able to get some better metrics on which features were important or significant.
So I have one question from online. How do you selectively use metadata from emails and use them as features? And what do you feel like examples?
Yeah, so there's a lot of metadata out there in sort of the envelope of emails, but we did a lot of trial and error again. Some of the interesting things that one of the interesting things that we used to predict whether a person was important or a contact was important was how quickly do you reply to them. So you can imagine, like, that's not part of the envelope of email, but it's like we have the whole email thread. We have every email thread, and we could figure out, okay, so in these chunks, how often do you reply? And complicated things like if you're CC'd on them, how often do you get in on the conversations, things like that. So there's a lot of data in the envelope. There's also in email. There's a lot of data on sort of the threads, the conversation, and the temporal stuff. Like as time goes by, what happens? And that's a much more complicated thing than sort of static metadata.
So you mentioned you're using MongoDB and Google. What other libraries do you use? What other libraries
decided those weren't for you and why?
We can talk later. But we definitely, so we used a couple of there's a lot of, we use Sparks. We played with Sparks and it works well. But it wasn't as, it didn't have as many gears and stuff that we wanted to play with. So TensorFlow had a few more. We used a few things. I would comment on every one probably. But so we can talk more. But we went through a lot. We used some syntax parsers that work okay, and we used them online, and we tried to play with anonymizing data, but that's not great. So then we played with some SyntaxNet stuff, which is a Google thing, and then we sort of transitioned away from that. And so yes, let's talk, because Sparks works well, and oddly the language of or maybe not oddly, I don't know, but the language of machine learning is Python. And I would love if someone could tell me why. I don't know why, but it is. I sort of think historically, people that were doing machine learning 10 years ago or 5 years ago, they were Python people, and that's how it just happened. I don't know. So anyway, someday I'll learn.
Well, thank you so much, David.
Thanks.
So just a couple items. We have some events coming up. On July 11th, we will be talking open data smart cities with Sensor Up. That will be a webinar. The presenter is out of Calgary, so that will be totally online. July 26th, we have IBM coming back. So for anyone who was here a couple weeks ago, the IBM talk was awesome, and there was a huge turnout. So that's July 26th. It'll be design thinking and how it applies to successful innovation. Also, there's space at the Data Hub if you need any, if your company needs any, so reach out to Communitech if you're looking for space. ODX just finished a cross-country tour where we went to pretty much every major city using open data. We interviewed the city, we interviewed companies in the city and how they're using open data, and we're releasing a report on that in the next couple weeks. So if you're interested in reading about that, definitely sign up to the newsletter. The newsletter will also give you information about upcoming events. And last piece, if you didn't have a chance to sign in or check in on the list, please do so on your way out, just so we have a general idea of how many people showed up. So thanks so much, and hope to see you again at the next event.
I've seen your